Hello friends, in the last lecture we have studied about series and parallel combination. While deriving the formula for series and parallel combination, we made some circuit diagrams, and in that circuit diagrams we used some instruments. So we would be studying those instruments in this lecture. The first instrument which we are going to study is ammeter. As the name suggests, as we know that SI unit of current is ampere, from that the name comes ammeter. So it is used to measure current flowing in the circuit. Its symbol, this is the symbol of an ammeter. I have written a positive and negative over here. Now what does this indicate? The positive terminal of ammeter should always be connected to the positive terminal of a battery, and similarly the negative terminal of a ammeter should be connected to the negative terminal of the battery for proper functioning. So it is used to measure current flowing. It must have low resistance. Now why it must have low resistance? As we know, it is used to measure current. So if it has maximum resistance, then minimum amount of current will flow through the ammeter, and we don't want that. We want that the maximum or the total current must easily pass through the ammeter. So it must have a low resistance. Ideally, it must be zero. The resistance of an ammeter should be zero ideally. But as we know that the instruments are not ideal, so they must have low resistance. Now, most important, it is always connected in series combination. Now, why it is connected in series combination? It is because, as we know and we have studied in the earlier lecture, that current remains same in series combination. So if we need to measure current across any resistance, the ammeter should be connected in series so that we can measure the current properly. Moving on, the next instrument is the voltmeter. And now it is used to measure potential difference across a resistance. This is the symbol of a voltmeter. Same positive negative sign. Positive should be connected to the positive terminal of the battery, and negative should be connected to the negative terminal of a battery. Now, as we know that in parallel combination, the potential difference remains same. This we have discussed in the earlier lecture. So, the voltmeter must be always connected in parallel combination, as it is used to measure potential difference. Second important thing, it must have a high resistance. Why this so? Because we don't want any current to flow through it. We want the current to flow through the resistance so that we can get a potential drop. If a voltmeter has a lesser resistance, then instead of flowing through the appliance, the current will flow through the voltmeter. So we won't be able to measure the potential difference across the appliance or any resistance properly. So in this case, we require that a voltmeter should have a maximum resistance, and ideally it should be infinite. Moving on, sometimes a question is asked in the exam that why appliances are connected in parallel combination rather than in series combination. In our households, all the appliances are connected in parallel combination. The same thing goes for the taps also. All the water supplies or all the taps, the showers, and whatever are the water supplies, they are always connected in parallel combination. Now why this happens? In parallel combination, the net resistance is less as compared to series. In parallel combination, we find out the net resistance by using the formula 1 by RT is equal to 1 by R1 plus 1 by R2 and so on. In case of series, use the formula RT is equal to R1 plus R2. So in parallel combination, the net resistance is low, whereas in series combination, the net resistance is high. Greater the resistance, we will learn in the next lecture, greater is the loss of energy. Second thing, in parallel combination, if all the appliances get equal potential drop. As you know, in parallel combination, the potential drop across each resistance remains same. So as all of the appliances in our household works at 220 volt. So if we connect them in series, most of the appliances won't be getting the sufficient amount of potential. But what if we connect it in parallel? In parallel, the V remains same. The supply is of 220 volt and each of the appliance will get 220 volt. So all the appliances will run smoothly and properly. The third, in parallel combination, if one of the appliance stops working, it doesn't affect the working of other. If I draw a diagram, let's say these three appliances are connected in parallel. What if I cut this appliance? The current will still flow through these two appliances. So even if one of the appliances stops working, it won't affect the working of other. But in case of series, if I cut this, the current will stop over here and won't be flowing to the next two resistance or the two appliances. So because of these benefits, the appliances are always connected in parallel combination rather than in series combination. Let us solve some numericals based on circuit diagram for better understanding of series and parallel combination. As you can see, I have drawn a diagram in which there are four resistance. One is of 12 ohm, second is again of 12 ohm, 6 ohm and 4 ohm. These are connected in this pattern across a battery of 14 volt. I have explained you earlier, if 14 volt was not written over here, we would have assumed this battery to be 4 volt. Two line indicates 2 volt, so there are 4 lines, so it will indicate 4 volt. But I have written 14 volt, so we'll assume that the potential difference of the battery is 14 volt. Now the question is asked to find out current. Now whenever we'll solve the circuit diagrams, we'll use the Ohm's law, and Ohm's law is V is equal to IR. So for finding I, we require R, that is R of the complete circuit. Now how to solve that? First we have to simplify the circuit. Now I've given the names R1, R2, R3 and R4. As you can see, R1, R2 and R3 are in parallel. Now how to identify parallel? Then all of them have the same starting and the end point. Secondly, the current divides in them. So whenever the current divides, it is in parallel combination, and if the total current flows, it is in series combination. So here the current divides, so R1, R2, R3 are in parallel combination. So R1, R2 and R3 are in parallel combination. This is a formula for finding out net resistance. On solving, I got 3 ohm. So on solving, the total resistance of this part, I get 3 ohm. Now this 3 ohm and this 4 ohm, this circuit can be simplified as, instead of this complete, I can draw a simple 3 ohm resistance. So 3 ohm and 4 ohm are now in series combination. So I will find out the net resistance. They are series, so I get 3 plus 4, 7 ohm. Now I have got the net resistance of the circuit. I have the potential drop. So by using Ohm's law, V is equal to IR. V is equal to IR. I will get I is equal to V by R. So 14 by 7, I will get 2 ampere as the answer. Let us solve some other numerical also. This is a bit a complex one. If such type of circuit diagram is there, how to start? So we'll start solving from the opposite end of the battery. Battery is connected over here. We'll start from the other end. We'll start solving from here. Now as you can see, as the current I flows, it comes to this point, it gets divided into two parts. One of the part flows through this and other flows through this. If let's say I1 is flowing through it and I2 is flowing through it. So as you can see, I1 is flowing through 10 ohm as well as this 10 ohm, that is through R1 and R2. The current is not further dividing. So we can say R1 and R2 are in series. Second way to find out, the end point of this is the starting point of this. So R1 and R2 are series. I'll repeat it once again. If such complex circuit comes, we'll start solving from the other end. So I'll start solving from this end. So as I can see, R1 and R2 are in series because the end point of R1 is the starting point of R2. So R1 and R2 are series. So I'll solve it. R1 and R2 are series, I get 20 ohm. Now on solving R1 and R2, I got 20 ohm. This 20 ohm and this 20 ohm, that is R3, are in parallel because the starting and end point of both of them are same. So on solving I got 20. So this 20 and this 20 are in parallel combination. So on solving RT1, that is the total of R1 and R2, and R3 are in parallel. So I got this. I got 1 by RT2. So I have to reciprocal this. On solving I got 1 by 10. But the actual answer will be 10 because I have found 1 by RT2 and you need to find out RT2. So you have to reciprocal the answer. Please remember this, you have to reciprocal the answer. So you'll get RT2 is equal to 10 ohm. Now I have done a simplified circuit. I solved the upper triangle and I got a total answer 10 ohm. So I have drawn a simplified circuit. Now as you can see, R4, RT2 and R5 all are in series because the starting point of R4, the end point of R4 is the starting point of RT2, the end point of RT2 is the starting point of R5. So all of them are now in series. So RT2, R4 and R5 are in series, so I get the net resistance to be 15 ohm. Applying Ohm's law, I'll get I is equal to V by R, that is 13 by 15. I get 2 ampere as the answer. Let us see one more example. Now to solve this circuit, again it is a complex circuit. We'll start from the further end from here. As you can see, the current is moving. As it reaches this point, it gets divided into two parts. Let's say I1 and I2. Now I2 flows through this part. It means R6, R5 and R4 are in series combination. So on solving that, I'll get 5 plus 10 plus 5, that is 20 ohm. Now on solving this, R3 and the solution of this has to be in parallel because the current is divided into two parts over here. So this resistance and the total of this resistance will be in parallel combination. So I have solved this, I got the answer 10. This will be now the simplified circuit. 5, 10, 5. The same thing which I taught in the last question. So these three are now in series. अब सीरीज में है तो टोटल ऐड कर लेंगे 20 आएगा. Again by using Ohm's law, V is equal to IR. So I is equal to V by R. I'll get 1 ampere. So this is the method of solving your question based on circuit diagram. In the next lecture, we would be studying to find out current through each resistance, Joule's law of heating and numericals on it. Thank you for watching.